we're running a little bit behind, but we have group 15. Group 15, whenever you guys are ready, please follow group 7.
Thank you, Dr. Garcia. Good afternoon, everyone. We are Pune Group, and we did our senior design project on the lifting aid for the wheelchair users. My name is Crutch, and to my right is Omar Al-Khadi, and Humam Il-Bati, and Amrita Charya, and Nicodemus Kilu. From here, Humam will explain the purpose and the background information on our project.
Good evening, everybody. Thank you for being here. I'm sure everybody of you know like how those people who use the wheelchair are suffering when they're using the wheelchair. Personally speaking, I used to live with my grandma, and she was a wheelchair user, and I used to see her struggle while she was trying to sit on the wheelchair or get off the wheelchair, and I was thinking about the solution. How can I fix the problem and how to make her more independent using the wheelchair? Me and my team were able to come with an idea to make those people more independent when they are using the wheelchair. How to make them able to use it without asking help. How to give them a standing position to get eye-level surfaces, and how to make their life easier. So we were able to implement an attachment that can be attached to any wheelchair to promote the independence of disabled people. For statistics, Nick will talk about it.
It's estimated by the World Health Organization over 3.3 million wheelchair users are in America alone. This number keeps on growing every year by around 2 million, especially with the aging of the baby boomer generation. From these statistics, we can see there is a need, and there will be a need of a lifting device. Now we'll hear about the challenges.
As a wheelchair user, a person is very limited to his mobility. They spend most of their time sitting on the wheelchair, and they are not like much involved into the physical activity like us. And as we know, like human body is just like a machine. If you don't keep moving it, it can get jammed. So due to the lack of the mobility, wheelchair users are facing all these health issues as shown in the slides. So we as a team were able to come up with an idea which would like solve most of these problems. So our product not only enables like a user to make themselves like lift independently, but it also makes them like lets them stretch their whole body. And also with the help of the anti-tipping support, they are able to prevent any injuries that could be caused by the tipping of the wheelchair. And Nick will be talking more about the solutions.
In analyzing what are the available solutions to the challenges, we were more concerned with the 60% to 80% of the injuries caused by falling. Most of these injuries come as a result of these people trying to reach for something which is either a distance from where they're seated or above them. That way the wheelchair trips from and then they get injured. To prevent that, they have in the market the small anti-tipping. If you see the size of those anti-tippers, it's limited. If you put more weight to a wheelchair, it's going to fall to the front. Then getting often on the wheelchair, they have these devices you can see up here, which are quite expensive. Most of these devices, you need someone to help you. You cannot use them independently. Omar is going to take you into details how they're used.
If we compare our lifting aid to the other lifting devices that are currently available in the market, our lifting design is operate very easily and maintained very easily too, and also provide the freedom and the independence to the disabled person to operate it and lift it and any time and anywhere in the bedroom, in the bathroom, in the living room without any assistance.
In the design development, our initial design was, we came up with on the wheelchair, we said, okay, we just need this person to be able to get off the wheelchair and get into a more elevated position. But we realized with the supports put on the sides, The moment the person gets off the wheelchair, their center of gravity changes and they can tip in the front. So we added the front tipping, but we attached them to the front of the wheelchair. So we fixed one problem and created another problem. Because now with the anti-tipping attached to the wheelchair, front of the wheelchair, then that means you need more room to maneuver around. So to counter that, we came up with our final design. On the final design, what we did, we moved this tipping from the front of the wheelchair to the side of the wheelchair, such that if you're not using them, you can push them back. If you want to use them, you can pull them out. Now, the final design has room for improvement, but as it is right now, it's functional. And from this 3D model, we extracted parts, mechanical engineering drawings, and assembly drawings.
Here's the attachment that we provided for the Carmen wheelchair with maximum weight 300 pounds. And as I said, this attachment can be attached to any wheelchair. So if you have an existing wheelchair, you can attach the product to it, and it's from aluminum and has 2 winches, and it's easy to assemble, bolts and nuts, and there's no need for welding.
And as we know, like any engineering design is followed by the mechanical analysis to make sure the design is safe. So in a similar way, we did the mechanical analysis on our design. So during that process, first of all, we did like some experiment to calculate some of these angles, which are the angles calculated at the different position of the user while they are standing or in the sitting position. So after that, we calculated all these stresses, including the normal stress, bending stress, shear stress, maximum deflection, bulking force, transverse shear, based on each angle. And after that, we were able to conclude that one of the specific angle, the 36 degree at this position, we were like able to calculate the high stress. So we were able to conclude that this particular angle, 36 degree, was the critical angle for our design. So after calculating the stress at the maximum load, which is 150 pounds on each bar, and at the critical angle of 36 degree, we were able to conclude that all the stress calculated were below the yield stress, and in that way, like, we were able to conclude that our design was safe.
We run some FEA simulation for the design using the inventor. And here shows the deflection while we're pulling the wheelchair with 25 angle. And shows here the deflection within the design limit is only 0.12, which is negligible. Also, the principal strain for the design is negligible. It shows you like it's blue picture, which is no change for the, there's no strain for the design with the maximum load.
As it comes to the operation of our lifting aid, is operate very easily by using 2 control buttons that provide an easy access to the disabled to get it in both position, the sitting and standing position. We need to follow some steps to add this video straight up. The first time we need to fold the foot steps, then you need to put the supporting bar to the front and lock them to make sure that the wheelchair is not moving or tipping, and then put the brake on to prevent it moving, and then attach the hooks to the harness on each side of the patient's shoulder. And then you start like, the easiest way, get to the right bottom control, so you're gonna operate and you start lifting himself very gently. And then when he got in the top, he's gonna try to twist himself and get the support from the supporting bar to make the twist very easily. And from there, he's gonna put it down and go to the sitting position. And the same steps is followed if you want to go from the wheelchair to the couch, and from couch to the wheelchair. And also, like, this lifting aid is not just for to go on and off the wheelchair. It's also given the standing position. to help in the disabled to reach like the items or the things is like around the level eye surface. And as you see here, like you can do it independently without any help, and from there you're gonna sit gently and gently like and provide like an easy access like for both and go up and down the wheelchair.
Some of the advantages of our Puna product are safe to handle, so there's no harm to any wheelchair user, and it's easy to use without any assistance from someone else. And plus it's affordable compared to the current market available solutions that we mentioned earlier in our previous slides. And it's easy to assemble, so the only tool we would need is just the adjustable wrench, which is shown here. And we did our cost analysis for the mass production, and our prototype cost was around $900, and the actual cost of 1 unit in the United States was around $625. And these charts shows the manufacturing labor cost per hour and location and cost of production overseas. So the total cost can be cut or reduced if the manufacturing was to be done overseas. So we found out that in Vietnam it was least inexpensive, and India was more expensive for our product. So if we decide to do mass production of 1,000 units or more, we would do it overseas. For the future consideration, we are considering to reduce the overall weight of the product and reduce the weight and the lifting capacity of the winches. Each winch weighs around 15 pounds. So we are considering something for more lightweight for our future design product, and also to reduce the number of fasteners on the product, and use the renewable power source and add flexible joints. And finally, we are considering to automate like these to lifting mechanism and tipping support for the wheelchair users' convenience.
In conclusion, our lifting aid is designed to improve the disabled life and give them some level of independence.
And also our product will increase the lifespan and the quality of the users. Thank you.
Now we'll take questions. Any questions?
So you did an FEA analysis on the actual system or the chair? Go back to your FEA analysis page. And what other simulations did you run there? Like the variance of the FEA analysis, you know, like the...
We are concerned about the deflection, because for the normal stresses, it's going to be very instantaneous while it's only here, and it was negligible for that given bar. But for the deflection, while we are making 150 degree as a maximum, we expect that there is a deflection. So we run that 150 pounds with the given angle, which is 36, and we got this deflection, and we said it's within the design limit, and with that support, our product doesn't tip, and did it tip.
What are the units on your stresses there? What does that say?
Here's everything is in unit in inch.
No, on the right side, the stresses.
Here's minimum.
Is that the strain? What kind of stresses did you have though?
This is not stress, this is strain.
This is a strain.
Okay, what kind of stresses did you have?
We did the normal stress, bending stress, but like we don't have all the simulation on the slides over here, but we have everything on our report.
What kind of stresses did you have maximum?
On the maximum, and if you look at the numbers,
for the maximum, the normal, maximum normal, and the other one, the deflection, and the backlink, all of them were negligible. So with the maximum weight on each bars, I mean, we didn't, I mean, it was too much with safety factor, so we didn't calculate, we didn't attach them on the slide, but in the report we have them in detail.
And what about, what design load did you use?
Mm-hmm.
What design load did you use?
Design load?
Yeah.
Why you have 150?
Because the
Why?
maximum weight for the wheelchair, common wheelchair, was 300.
That's the weight of a person.
The weight of the person. So we calculate according. But our attachment can be able to lift up to 2,000.
Okay.
You know, each one able to lift 1,000 pounds. But the wheelchair itself that we attach, our design was 300 only. So by symmetry, we said 150 on each side.
Where is the weak point on that frame?
I can tell you here. On the hinge. We did not design those to do our limited resources, but we run many testing on those things, and I can tell you without engineering, I'll tell you this is the weakest point.
I would agree. From a structural point of view,
Exactly.
the weakest point is going to be that hinge.
Exactly.
The moment, not just the shear, not just the vertical force, but the moment on that hinge. And that's what you need to focus your limit on. And your, what kind of factor of safety do you use?
For the winches, you know, it's, we said it's 1,000, and our load was only 150. So also, if I said
What is the capacity of this?
of the winches, there was about it's close to 150. Was each one is about 120 pounds, but for gates. I use them for gates. This one is a hinge for gates.
And it's only going to hold 120 pounds.
120 pounds, yes. At that moment, yes.
So if you have a 300-pound person, and they
on each.
so yeah, so if you have a 300-pound person, that's 150 on each. If you add any dynamic amplification, say somebody moves really quickly or jolts really quickly, you could easily double that weight. So you could have 300 pounds on that one of those just one of those hinges very easily.
Dynamically speaking, yes, that's true. But it's a wheelchair, so we neglect the dynamic. We didn't also run the dynamic analysis on the design. But for future consideration, if you want to do that, yes, we're gonna consider that
So
dynamic, and while you're lifting that thing, and if you are moving.
For example, you're lifting somebody up. They reach for something, they slip, and they go back into the wheelchair. Dynamic amplification.
Also, yeah, there is impact. You're right.
Yeah, so the question again is maybe I missed it. In the early part of your presentation, this is not reinventing the wheel, right? This is something new. Or how do you compare with the existing market? They have something this already.
No, in the market currently, what they are is devices which you need somebody to help you. They are like a patient, okay, you see, this is what they have in the market currently. You need someone else to help you to use these ones. Either they will tie the strap on you, get you on and off the wheelchair. But with ours, you can do it yourself.
Okay, so
Yeah.
this is the improvement.
Yeah,
Okay.
you can call it that.
Okay.
I think I just want to add a point. In the market, there is a sealing machine which can hold a person, disability person. Sealing, I mean, it comes under the sealing where it goes and takes it wherever they want to go. Yeah.
But you see, with those ones, they're quite expensive. I guess it's few people who can afford to put that in their homes. But with this one, let's say it's advanced in its making, you can just buy the parts, attach to your wheelchair, and then you have mobility.
Our goal was just to make those people able to operate and lift themselves, get off the wheelchair and get in the wheelchair by themselves without help from other people. So this is the main idea.
What is the increase in force needed to operate the wheelchair just in normal forward motion with the attachments versus the standard state? In other words, okay, there's a lot more extra equipment added to your wheelchair, so there has to be some increase in propulsive force. Is it 5%? Is it 10%? Is it 100%? How much more difficult does it get to operate that wheelchair with all this stuff attached to it?
So the weight of the wheelchair itself at first was like 50 pounds, and whenever we attached like everything on it, so it came up like about 95 pounds.
Okay.
So like when you calculate the proportion, I think it goes up by like maybe 60 or 70%.
Okay, so that's quite substantial. Okay. So that's something to keep in mind. Yes, you're making it easier for them to do the one task of getting them up occasionally, but you're making it much more difficult for them to get around all day long because they're carting around the lifting frame wherever they go.
Yeah, that's right. And also like he talked about in the future consideration, that's what like we're considering in the future, making it like more lightweight.
And also plus make these like automatic these entity first and the
Make those telescoping supports.
Any further questions?
One other one. Have you, one thing I would have liked to see, okay, I don't mean to harp on your everything, I like that, this is good, this is very innovative, I am liking a lot what I'm seeing. One thing I would like to see is, I saw, which one of you was in the video? Okay, that was nice and all, but what I really would have liked to see is, I would have liked to see a video of someone who actually uses a wheelchair regularly.
Yeah, if you see the first video, like I was trying to not using my legs. So I was, if you go to the video, like you see, like I was off the ground completely. I wasn't using my legs. That's why I was like to go to the video, like at the end. So that's why like we were trying to be like disabled. That's why I put all my weight here to also to make sure like everything working. I'm about 200 pounds, and it wasn't lift me like very smoothly. And you see here, and I push myself, and also like I put all my weight here in the supporting bar, and it was like very gently to operate.
I understand what you meant, getting a disabled person to do it. Because of legal implications, it's not approved. We could not do that. So that's why we chose one of ours.
Okay.
Any study you have done on the liability based on what you already have on the market? Because this is associated with the patient or the client, right? On device like this, liability and also the risk analysis. Have you ever considered that?
That's a good point. We did not do much research on that, but it's something to put into consideration for future.
And also, again, the video is wonderful, right? So you did a wonderful job on this. But consider you are the healthy young person. If I see what you did there, can you try to imagine a 60-some-year-old or 80-year-old person have some kind of a health situation? Can he or she really handle that? That's again, you need to be considered again the risk, all this stuff.
You see, well, with the let's say in the future, when it's much more improved, it's going to be more automated. So any person at any age is just like clicking a button. Thing lifts you up, puts you back down with a lot of comfort and easiness.
But the concept is still like if you want to make somebody sit on the wheelchair, you are going to use the harness. We use the harness, but we operate it differently. So this is what we do.
Very good. No, I like the idea.
Thank you.
I think that's something that needs to be considered in this case, and some of the suggestions pull into that direction is that I will heavily encourage the group to access a facility with seniors or people with limited mobility, a nursing home, etc., and try to see what is the reception from an end user that actually needs this. Because there has to be several different situations, one of them is real life. And see what it is. Because real improvement comes when the thing is in use. Maybe the next step won't be driven by any of the assumptions that we are having right now, but what something in real life is going to happen. So sometimes we can speculate all along technology and all these things, but maybe this thing was really all they need. Or, there has to be an improvement on these things and items that will actually pull all the liability into this thing. But once again, always trying to encourage the end user for whom you decide to actually try. That's
Also, also one thing, that wheelchair that you have that on, is that one that's designed to be operated by someone, only by someone pushing it? Because I see the handbrakes on the back.
They're just to
No,
recline.
It's not a handbrake. It's just like when you press it, you can recline.
Okay, so that's not actually,
Recline
okay,
function,
okay,
yes.
those aren't handbrakes, gotcha.
Yes.
Okay, so
The
those
brakes
aren't
are still
handbrakes, never mind,
on.
okay.
Well, would like to thank Dr. Andres for the help during the whole procedure of making this thing work.
Thank you.
Thank you, Drew.